H over D. So this H represents the hypothesis. H represents a hypothesis. D represents the training examples or training data. Okay, so this probability, Bayes theorem is based on probability. So now what are we learning? Though we have learned some of your classification algorithms or supervised algorithms, Bayes theorem also provides a reason why you should learn, because it is a probabilistic approach to our inference. Means whatever the inferencing you are making based on the training examples, you develop a hypothesis, and based on that hypothesis, you classify the new set of example and you predict this could be that, this could be this one, right? Based on the class of whenever classes you have. The same thing we can do using Bayes theorem, but it is a probabilistic approach. Means it will not clearly tell you, so this is the class of an unseen data. Instead, it will tell you this would be the probability of this unseen data to be of class X, or it could be the probability of unseen data to the class Y. We all know the whole sum of probability is 1. So whatever the probabilities we take, it should sum up to 1. Correct? So with that basic knowledge, let us go forward and see why would we go for this Bayes theorem or Bayesian learning. Though most of the problems could be addressed or solved using neural networks or using decision tree, some problems still are suitable for naive-Bayes classifier. Okay. The features of Bayesian learning methods include some incremental increase or decrease in the estimated probability that a hypothesis is correct. Okay, so you should have a prior knowledge of your data set and the hypothesis when you are going with your Bayes theorem. So that is very, very important. So we have this P of H representing P of H representing the prior knowledge over the hypothesis. P of D is also a prior knowledge, which could also be called as evidence. Probably you have heard of that term, evidence. Okay, so these two are prior knowledge, and this is your posterior knowledge or posterior probability. I can tell P of D and P of H has prior probability, and P of H over D as posterior probability. P of D over H is my likelihood of belonging this training data set to the hypothesis H. Okay, what is the probability of having this hypothesis is given by P of H. What is the probability that this particular data set is observed is given by P of D. And what could be the probability or likelihood of having D belonging to H is given by P of H or D. When you know all of them, you can find out whether this hypothesis H can give the probability of classifying this new data sample D. Okay, so that is the basic of your Bayes theorem. Next, you have lot many equations and derivations in your textbook. I'm not going to discuss all of them. Instead, I'm going to take whichever is needed for my experiment. Okay, so it depends on data, what kind of data we have got to apply different Bayesian classifiers. So Bayesian classifier basically is not one classifier. Instead, it's a family of classifier. It comes as a family. It has some 3 to 5 different approaches, which you could use based on the data set that you get. Okay, so you should be very, very clear with on what data set you are applying it. So whatever the data set we are considering as mentioned in the problem statement, it should be the data set that is stored in a CSV file. So we consider this data set as a continuous value data set. It could be discrete also since they have not mentioned, but we will take it as continuous data set. You should also make this as a point when you are understanding the program. Okay, we are taking continuous valued data set. So what do you mean by continuous valued data set? Like image we saw in the yesterday's class, that is also a continuous value data set. Video, it's a continuous value data set. Discrete, means it will have a very specific values like 0, 1, 2, 3, something like that. But when it comes to continuous or real value data set or data, it will have a very, point 0.1, point 0.2, point 0.25. These are continuous values, right? You don't have fixed specific value. So it will be kind of a mixture of or a range of values, right? Like height is an example for a continuous value. Weight is an example for a continuous value. But when it comes to today it will rain or not, you will tell yes or no, correct? So if I tell with the probability, it may be probability, it may convert into continuous value. So that depends. So what kind of value or data set you are making use of. So here we are considering continuous value data set. So whenever you go with continuous value data set, we will be using maximum likelihood. ML represents not machine learning. ML is not machine learning. ML represents maximum likelihood. Okay. So this maximum likelihood is given by this formula R max of the hypothesis H, lowercase h, belongs to the hypothesis space H. Hypothesis space H means the collection of all possible hypotheses. Is given by phi. Like the way summation represents sum, this represents product, okay, multiplication. Product of 1 over 2 square root of 2 phi sigma square. This is nothing but your standard deviation. Okay, standard deviation into e power 1 over 2 times of sigma square into di minus mu whole square. This mu is nothing but your mean.
ನನಗಿದು ಲಿಂಕ್ ತೊಗೊಳೋದು ಗೊತ್ತಾಗ್ತಾಯಿಲ್ಲ.
Okay, so why are we using this? You may have this question, why this formula? Why are you using this? So this is based on Gaussian distribution. Probably you have heard of this term, or normal distribution curve. Right? I don't want to complicate things. I'm just keeping it simple.
ಯೂಟ್ಯೂಬು
If
ಲೈವ್
you have
ಹೋಗ್ತಿದಲ್ಲ
doubts, you can ask.
200.
Okay, Gaussian distribution or normal distribution. You will have this in your textbook, but not in detail. But slightly it's there.
ಗೊತ್ತಾ
But you will get it in various sources. It's very very important term whenever you talk about continuous valued input or data set. This is kind of a
ಗೂಗಲಲ್ಲಿ ನೋಡಿ.
inverted bell-shaped curve. Okay, so this is how it looks like. Bell-shaped curve, which will give the values of the data set with respect to the variance and the mean. Okay. So when to use this Gaussian distribution or normal distribution? When you have a continuous valued inputs. When you are dealing with continuous valued data, we will refer to this Gaussian distribution. Based on this Gaussian base classifier, this is the formula to find out the maximum likelihood
ನಾವು
of a hypothesis. So what do you mean by maximum likelihood of a hypothesis? It could be the maximum chances of this hypothesis, which could give me the proper classification or a probability or a classification. Maximum chances we will see how are this hypothesis, which could give me the proper classification or a probability or a. So what is this? You see one more formula here. Very simple formula, right? Not complicated like this. LHS is same, half part of your RHS is same, but here you get a difference.
ಸ್ಟ್ರೀಮ್ ಆಗ್ತಿದೆ.
Correct? So this is used to predict for new sample. This is used for predicting for a new sample or new data. Then what is this for? This is for training.
ಹೆಂಗೋ
Okay? So even in this, in the base classifier, we go with training and testing data, but the one more advantage, you can make a note of it, one more advantage of Bayesian classifier is it don't need much of training examples. Okay? But when it comes to neural network or decision tree, you should have a good number of training examples. But when it comes to Bayesian classifier, you don't have to have a good number of or a huge number of training examples. A sufficient number is enough. Okay? Some reasonable number of this one is enough. Okay. I hope this formulae are quite clear. I'm just taking you to example. Maybe basic exercise, right? This example is straight away driven from your Wikipedia. You can just Google it. Bayesian classifier. You will get the same example, but it's very interesting example. So I wanted to show you the same thing, and even in the output we have got the same. Okay. One slight difference is there that I'll tell you. Right? So what is this problem? How is this example going to work? See, this is about whether a given person is male or a female based on the measured features. So features are given here. So this is your training set. Okay. Usually your classification, person is the target concept or classification. Usually that comes to your extreme right. But here they had given to your left or the first column. But that logically makes no difference. What are the features you have? You have height, weight, and foot size. Three features you have. So based on these three features, the person has been classified as female or male. Okay. So this is a continuous value. Please understand that, student. It's a continuous value, right? So height is given in feet, is given in lbs, and foot size is given in inches. You can change it to your Indian standards like kgs and centimeters, whatever. Okay. These are continuous values, right? So for this kind of continuous value, Gaussian distribution gives a very clear, you know, uh, classification. That's why we go for Gaussian distribution. So in Gaussian distribution, you saw the formula. So to calculate that formula, you would need mean and variance of each and every feature. Okay. So that's why we are finding out the mean and variance of each and every feature with respect to each and every classification. I mean to tell, the classification is second table. Please refer to the second table. It's male and female. Okay, two different classifications I have. So with respect to male, what is the feature? Height. Height is one of the feature. So I'll find out mean of your height. I hope you know the formula of mean. Correct? How to take mean? How to take mean? Quite simple, right? Take all of them, divide by the whole number. Correct? Next. Um, Next thing what I should find out is variance. When it comes to variance, variance because it's sigma square. Because it's sigma square. If you just take sigma, it's a standard deviation. Correct? Sigma square is standard deviation square is nothing but variance. If you just take standard deviation, so I have a formula for standard deviation. You have to just make a square of it to get your variance. So, what is the type of standard deviations we have? We have two types of standard deviation, population standard deviation and sample standard deviation. They have used sample standard deviation, hence they are making use of standard variance. There is very small difference between population standard deviation and sample standard deviation. The denominator is different. In population standard deviation, denominator is n. In sample, the denominator is n minus 1. Okay. So that is the difference. So you are going to find out the mean and variance per classification per feature. Okay. Mean and variance of height for male, mean and variance of height for female with the help of these values. Okay. So for male, these are the ones. So take these four values, find out the mean and variance. And for female, take down these four values, find out mean and variance. Similarly, repeat for weight. These four values for male, these four values for female, and foot size, these four and these four. Okay, that's how I generate this table. Please remember all of them. Programmatically also we are doing this. We will be generating these tables. Okay. So after you generate this table, we would need to test the new sample. This is my new sample. Okay. The new sample, I don't know the classification. I have to predict the classification. For this new sample, the height is 6, weight is 130 and food size is 8. Okay. So we wish to determine the posterior probability based on the posterior probability of male and female. Okay. The posterior probability of male is given by the probability of having the sample as male into the probability of height of this new sample belonging to classification male, probability of weight belonging to male, probability of food size belonging to male, whole divided by the evidence. Okay. Similarly, for female, probability of the sample being female, probability of height being of female, weight being belonging to female, and food size belonging to female divided by the evidence. So what could be the evidence? Evidence will be also termed as normalized constant, may be calculated by probability of male, the whole sample, into probability of height being male, weight, food size, plus probability of female, height being female, weight being female, and food size being female. Right? So this is how you get the evidence. So now I have to just apply this formula. So I should have a prior knowledge of the whole data set. Means this P of male and P of female. Since in this training set, what you can see is out of 8 examples, 4 belong to male and 4 belong to female. I'll take equal probability. I'll just predict my prior knowledge could be zero point 0.5 and zero point 0.5. The probability of being male is zero point 0.5. The probability of being female is zero point 0.5. Okay. So after that, I have to find out probability of height being male. So here is where I have applied the formula that I showed you in the slide. So this formula, I am finding out this part. 1 over square root of 2 pi into standard deviation square, which is nothing but variance, into e power 1 over 2 variance into di minus mu whole square. Okay. So di represents your new data sample. So for height it will be 6, for weight it will be 130, for food size it will be 8. See, I am calculating for height, so I have considered 6. So what should I take? Mu. I have to take it from this table. Okay, what should the variance I should take? I should take from this table for male. I am calculating for male. Okay. So I similarly substitute it and I similarly repeat for weight and food size of the male. Okay. In the same way, I do it for female also. In the same way, I do it for female also. But the posterior probability is given by this whole thing. You have to multiply them. Correct? So I'm just avoiding the evidence. Their product I'm taking and because both the way evidence is there, right? I'm comparing between them, so you can ignore evidence as of now. So I'm multiplying 1.5709 into zero point 0.5, zero point 0.5 into 1.5789 into 5.9881 into 10 power minus 6 into 1.3112 into 10 power minus 6. So this is the product I get. Similarly, I multiply all of them for female and this is the product I get. So, to predict the new sample belongs to which class, I am just applying this. Okay, very simple thing. So, I am doing this and I am just applying R max thing. Sorry, I am just applying the R max. Means, so maximum out of these two. Which one is maximum? Female is maximum because it's 10 raised to minus 4, right? The posterior probability of female, which is 5.3778 into 10 power minus 4, is greater than 6.1984 into 10 power minus 9. Hence, I predict this new sample might belong to the class female. This should be of class female. That is my prediction. Understood? Since it's continuous valued, we applied this Gaussian distribution and we did. In the next example, you will see we have different type of data. Okay? And I'll show you one more problem where you get normal discrete type of data, how to do. That also you can do, not an issue. Is that clear? Are you following? Any doubts you have? Let me check the chat box. Yeah, okay. If you have any queries, you can just drop into chat box, students. I'll just wait for some 30 seconds and then continue with the program. If you are okay with this algorithm and the problem discussion, we can move to program. And the links also, as I mentioned, this is in your Wikipedia. You can just Google it for your further study or understanding. You can refer to the same example so that it will be easy for you, right? Okay. So I'm not getting any response. I'm moving to the spider window. I hope the spider window is visible. Fifth program, right? We are supposed to run fifth program. Quite a lengthy program. You should concentrate for the explanation or else you will miss the track. So normally what I do, I just number the functions and the call of the function so that it will be easy for my students whenever they do it. Like first function call, second function call, like that. You can also do it, but in this I cannot write. Spider don't allow me to use the pointer. Let me clear this console. Okay. Fine. What are we doing now? We are implementing naive-based classifier for concept learning problem. You can apply this for, a play tennis example also. It works fine, but it is meant for continuous value. So only I have changed the data set into, I'll show you, gender classification, whatever we discussed. The same example I had put. This is your height, this is your weight in lbs, this is foot size in inches, and this is the classification. 0 represents male, 1 represents female. Okay, so only till here you consider 1, 2, 3, 4, 5, 6, 7. Only 7. Okay, other two I have taken it for uh, new predictions. Okay, other two I have taken it for predicting, because in the question they have clearly mentioned, right, that you have to give the classification for the new set of data. So I had taken two for predicting, right? So this program, it's quite lengthy, and usually students find it a little difficult. So I'll make my best effort to make you understand it. The only thing is you have to just come along with me and you have to recollect the problem, right? If you can switch between the windows, you can just type in your Google Wikipedia link for naive-based classifier and open that so that it makes your job easy to compare and learn. So it is made up of some 6 to 7 functions. One function, uh, okay, we have important CSV and math. One function, safe division, very basic function. I don't want divide by zero error, that's all. Okay, to avoid that divide by zero error, I'm using this safe division. Then load CSV, I'll just tell you in a brief what are these functions. Load CSV is to load your CSV file and convert the data set into an array form. So I'm storing a floating point array or a matrix form. Then split data set based on the split ratio, because the whole data set is here, whole complete 9 data set are there. You can just divide into 30%, for 60% of training and 40% of testing, or 70% of training and 30% of testing. So for that, I have that split data set. Based on the ratio, it will split and it will give. Separate by class, as the name itself tells, based on the classification, male and female, it separates. Okay. Mean, to find out the mean based on the class. Standard deviation, to find out the standard deviation based on the class and the feature. Summarize, we are going to put them together. Okay, we are going to put them together, mean, standard deviation, everything. Then summarize by class. So this actually calls these functions, separate by class and such functions. This is called from the main part. Okay. Then these two are for probability calculation, the Gaussian function and the calculation, the rest of the calculations. And this is for your prediction. So you have to predict for the new samples, right? So you predict, this function calls your predict. Then here you check whether your prediction is correct. So based on the correctness of your prediction, you display the accuracy. Okay, so that is the overview of the program. Here you can see, so learning program split 9 rows into, I have 9 rows, right? I showed you, I have 9 rows. So these 9 rows I'm splitting into 7 training data and 2 testing data, because I had taken the def main. So main function we have, like we had not seen main function in any of the programs till now. I had included that here so that you will learn different type of syntax. Okay. So split ratio had given it as 80%. For 80%, 80% out of 9. So it will give me 7 point something or 6 point something, which will be sealed or flowed to 7. Remaining 2 is for testing. Okay, so that will be done with the help of split dataset example. I'll take you to the function later. I'm just making you to understand the output. Then the values assumed for concept learning. This you can ignore. As I told, this will also work for Clayton's. I'll show you. It will also work for Clayton's. The same 010101 example that we have taken in your ID3 algorithm. Okay, same example also you can give it as the input, just the dataset name. That dataset also I have. You can give different dataset. Okay, it works fine, but they are not continuous. So just to match to our why we need Gaussian distribution explanation, I just used it. Okay, it works fine. It works fine for discrete as well as continuous, but it is meant for continuous value dataset. Okay, so since we are using this part of output is for that experiment, that data set. So if you are not using Clayton's experiment, you can just comment all these prints. Okay, you can just comment all these prints. Oh, let us go back to gender classification. Okay, so I'll just work training with them. Yeah, so these things I don't want them. So I have just commented. So this works fine for my gender classification example. So I have 7 training data and 2 for testing. So then what is it displaying? It's displaying all this training and testing data. Then it is printing the actual classification, which was here 1 and 0. The predicted classification is 1 and 1. For both it has predicted as 1, 1. So here is a misclassification for the second data set. Hence the accuracy is 50%. Okay. So let us go in detail with the program. So from here it starts, main function, file name is genderclassification.csv. So After you get the file name and you specify the split ratio, you need not give the split ratio as 80 all the time. You can go with 70 or 60, suggestible 70 or 80. Then you are going to call load CSV. So what is your load CSV going to do? It is take the file. It will take the file name and it calls the CSV reader to open the file. Once it opens the file, it reads the lines from the file and it converts into the form of a list like an array. Okay. So this one is getting converted to a floating point value and that will be placed. Suppose it's already in float, it's not going to make any difference. If it is not in the floating point value fashion, it will be converted to that format and it will be displayed. So now you can see you will have multiple lists like this. Okay, that is the job of load CSV. Then it comes back to main function and that is assigned to dataset. Then you call split dataset function. This split dataset function takes two parameters. What is that? Dataset and the split ratio. Dataset is the whole 9 example. You are going to split into the ratio given. So 80% length of data set would be 9. 9 into 80%. So you will get some value. So that will be your train size. Okay. So until unless train set which is empty, the length of train set will be obviously 0. Until unless it becomes equal to train size, I'll be just appending the contents. One thing what you should observe is I'm popping the content from copy. So what is copy? Copy is the list of your data set. Whatever data set you had, that is copied to the variable by name copy. From copy, I'm popping. I hope you remember the stack operation, push and pop, right? From the topmost, it is going to remove the elements. The first row, second row, third row, like that, it will remove till the seventh row. Seventh row also, it will remove. Once it becomes equal to 7, it comes out. And as I mentioned in yesterday's class, Python has this beautiful feature of returning two values. So I'm returning two values, train set and copy. Okay. So train set will be those 7 values and copy will be left out with only 2 values because we have popped, right? We have popped. We have not just copied, we have popped, right? So that returns to the main function. So in the main function, training set will have 7 values, 7 rows and test set will have 2. That is what we have displayed. Then for each of the training set, no, this is just the print of it. Yeah. So for each of the training set, you are calling summarize by class. Please go back to this example. What is this example that I showed you? This one. What did we do? We constructed a table with male and female. We have segregated the data into male and female and we started calculating mean. The same thing will be done by this summarize by class. Okay. What is the summarize by class going to do? Summarize by class is going to call separate by class. So that's why I told you, give the number to the function call. So this function is calling separate by class. Even in your Python, since it's an interpreted language, you should be defining all the functions before the function call. Means separate by class should be on top of your uh, function summarize class by class. Okay. So separated will be empty. All for all the data set, your for loop is going to work. Take each one of them and check what is the last column value. So last column will usually be classification. Okay. So if the classification is already there in separated array, so it will just add that. Okay. If the classification is not there, it is going to create the classification. So first time it has to create an array. Okay. So first time, first row, right? First row classification is 0. 0 is not there. So it will create an empty array. Then what it does, it goes to the next iteration of the for. It takes the second one. Second one is also 0, but 0 it's already there, so you append it. Right? So it is going to separate these 4 into one group and these 4 into another group. Separated of 0 to this one, separated of 1s with this. right? So that will be the output by separate by class. So separated will give me two arrays, a list, one list with all class as 0, another list with all of the data set with class of 1. With that, separated dot items means you will take these, you will read one by one. What is the class value? 0. What is the instance? The first instance. Okay. So you are going to call summarize of instances. So what is your summarize going to do? It is going to call mean and standard deviation for each of the attribute in zip of your data set. So the zip, like you compress and put them together, very similar to that. Your zip is going to consider uh, the whole data set what we have, the whole data set what we have. This should be taken one by one because this is height, this is height, this is height, and this is height. Similarly, this is weight, and this is your foot size. They're all different, right? So I should take them column wise. So that will be done, and that will be passed here to your mean and standard deviation. They will calculate the mean and standard deviation with the formula normally what we have with the built-in functions, and it is going to return it. So once I get that, I would no more need the classification because as we saw here, we no more need this male and female for the further classification. So I would need only these values. Okay. So male height, mean, male height variance, like that. Hence, I am deleting the last column. Summarize last column, I am going to delete, and this will be written. Where is it getting returned? This is getting returned to summarize by class. Okay. So summarize class value, which will be 0, will have, means male, will have all its mean and variance with respect to height, weight, and foot size. Similarly, it is repeated for female. So together it's going to work. So that is summarized by class, which is called by the main function. Okay. So basically this table is ready. Next, what we should do, we should take the new sample and we should calculate this. Correct? So now I'm going to get predictions. So I need the summaries, whatever the table I have developed. I need the test set. Test set means new data. These two, last two rows. Okay? So that will be sent to your get prediction. Come to get prediction. In get prediction, summaries and test set. Prediction will be initially an empty list. Then for each of the test set, you are going to call predict function. So what is predict function? It takes summaries and input vector, which will be one row at a time. So let's say this row at a time. It calculates class probabilities. Calculate class probabilities for summaries and input vector. So what is this calculate class probability? Is nothing but your Gaussian function, Gaussian distribution function. Okay. So here what we have is calculate class probabilities, right? Is there anything like, yes, calculate probability. This calculate probability will give you that e power thing, e power 1 over 2 times of variance into di minus mu whole square. So this it will give. Then that is used in your calculate probability because I have to multiply them with respect to each one, like this one, right? So we have to find out this 0.5, 1.5789 by applying this formula. So that will be done with your calculate probability. Calculate class probability is multiplying 0.5, 1.5789, 5.9881 into 10 power minus 6, and 1.3112 into 10 power minus 3 and getting this product. So that will be done by calculate class probabilities. Why? Because see, you are calling calculate probability with respect to the class value. Okay. What is the probability that this new set of example belong to class 0? What is the probability that new example belong to class 1 or male and female for our example? That is going to be calculated here. Okay. So after this is done, you are going to test which one is having higher probability. Okay, best label is none or probability is greater than best probability. Best probability, I'll just take it as -1 and I continue. Once I get the prediction, best label could be this particular class value. So you are going to update into the array that we have created here. Get predictions. Okay. So once we do this, once we update this, we are going to compare that with our actual value. Okay. We are going to compare that with your actual value and then put your actual value accuracy. Then put your accuracy. For that you are calling your get accuracy. What do you do in get accuracy? You are going to just count if the number of predictions is equal to test set of i's minus 1. Test set of I represent row wise the test set, minus 1 represent the last column, which will usually be the classification. That is compared with the predicted class value, which is the classification that you have predicted by get prediction. If this is equal to this, count will be incremented by 1. So you keep doing it, then you divide the whole thing from the count of test set and you multiply by 100. That gives you the accuracy in the form of percentage, and use some format to display it in this particular format. Okay, it should support the format, right? So like space holders or something like that in your Python, we have done that and we have printed this result. Okay, so that completes your program number 5. If you have any doubts, you can unmute and talk, or you can just drop into chat box. Anything you want me to repeat, then also you can tell. No problem. I can repeat you in some more detail you want, I can do that. Please feel free to talk, students. No? At least type in that if everything is okay, just type in, we can go with next program. Can we proceed with next program? Yes. Okay. So I hope you are recording. Yes. So you are recording. Good. You can refer to it later, but you will get your doubts clarified here if you speak. Okay. Okay. Thank you for your responses. Fine. We will go with the next program. So I thought I would have to write something here. I'm not writing. Okay. Program number 6. Assuming a set of documents, very, very important term, documents, they're like your files that need to be classified. You have to classify the documents now. Use the naive Bayesian classifier model to perform this task. Built-in Java classes bar APIs can be used to write the program. Calculate the accuracy, precision, and recall for your data set. Okay. Very, very, very interesting problem. And even in any research paper for technical seminars or for projects, probably you would have seen any text classification like I give handwriting analysis also. You can use this. NLP is there, but you can still use naive Bayesian classifier, and wherein you will have some documents. You have to tell whether that document belongs to the categories, or you have to automatically separate the emails as spam. Okay, very important application of this. You had got an email. Nowadays, what we see, our spam emails directly goes to the folder spam, right? It doesn't trouble us in our primary inbox. It goes to spam, and even promotion goes to promotion. It automatically happens, right? So this could be the algorithm running behind it, or some advanced algorithm. So what is your basic of Navy Bayesian classifier is, again, it's based on Bayes theorem, based on probability. But the thing is, it can classify the whole document, okay, into separate groups. It can classify the whole document into separate groups. One more thing, all these three algorithms, what we are learning, they are also supervised learning algorithms. Okay, they are not unsupervised, they are supervised learning algorithms, they are the classifiers. Okay, so how is it different from the previous one? The data is not given in a CSV file. You cannot have the data in the CSV file. Instead, the data is given in the form of a document. So